Hello, and these are the notes for Unit 8, Day 2. So let's see this. We are going to rationalize the denominator because you cannot leave a square root in the denominator. All right, but first thing we need to remember are these perfect square numbers. So make sure you're getting a handle on those and how to figure out what they are. So the perfect squares are numbers to the second power or squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So these are my perfect squares. The list in red. Kind of look at those and be able to refer back to these when you need to, when breaking down square roots. Words of the day, terminology, words of the day. A radical, the inverse of a power, it's often called the roots. I may say the word root. Index, the power of a root, small number in the basket of the radical. We'll talk about that in a minute. And radicand, the inside of the root. So what's under the square root sign is what that means. All right, the square root is an exponent. So what that means is if I say the square root of x, remember that means the same as x to the 1/2 power. So it has an exponent of 1/2. Remember from yesterday when I have the square root of ab equals the square root of a times the square root of b. For instance, if I have the square root of 12, that equals the square root of 4 times the square root of 3, which you could simplify then as 2 times the square root of 3. Likewise, if I have the square root of a over b, so let's say I have the square root of 50 over 2, that's the same as the square root of 50 divided by the square root of 2. So the square root of 50 is the square root of 25 times the square root of 2. So then the numerator, I have 5 square root of 2 divided by the square root of 2. And you can see that can go away and get just 5. All right. Let's look at the next one here. Radicals do not distribute over addition. Don't look at the puppy. He just isn't going to, he is going to cry. Every time you do this, a puppy cries. Because that looks just like my puppy. All right, so, but every time you cannot, this does not equal, let me find a purple pen here, does not equal square root of 25 minus the square root of 16. Because the square root of 25 minus 16 would be the square root of 9, which is 3. Square root of 25, so let's do that. So square root of 9, which equals 3 on this side. And then the other side would be square root of 25 is 5, square root of 16 is 4, and 5 minus 4 is 1. So these are not equal to each other. Don't do that. Likewise, the square root of 25 plus, or x squared plus 25 does not equal x plus 5. So keep that in mind. Star these. Don't do that stuff because a puppy will cry. A square root is not simplified if the radicand has a factor that's a perfect square bigger than 1. And to reduce a square root, rewrite the radicand as a product of 2 factors using the biggest perfect square that is a factor of the radicand. Ooh, what's that mean? It's what we did yesterday. So square root of 147, I'm looking at that list of perfect squares. I'm going to write these up here. So perfect squares would be, first one I'm going to use is 4, 9, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 84, no, 8 squared, how about 64, 9 squared 81, 100, and so on. So in 147, what does that divide by of that list of numbers? So 147 divided by 4? Nope. 147 divided by 9? Nope. 147 divided by 16? Not that either. 147 divided by 25, definitely no. 147 divided by 36, no. 147 divided by 49, yes. So I'm going to rewrite this as the square root of 49 times the square root of 3, because 49 times 3 is 147. Simplify this some more. The square root of 49 is 7 times the square root of 3. That is my final answer. All right, 320. It divides by 4, right? So 320 divided by 4 is 80, but 80 still divides by 4. So I'm thinking this divides by 16. Ooh. So I get square root of 16, square root of 20. But 20 still divides by 4. So let's do 320 divided by 64 is 5. So I'm going to break this down as the square root of 64 times the square root of 5. So finish that. You get square root of 64 is 8 times the square root of 5. Now, let's say you forgot and you're like, and you get 4 and you think, I'm just going to go use 4 because it divides. So another option could be, you could do square root of 320 equals square root of 4 square root of 80. Well, 80 still divides by 16. So I'm going to write that as square root of 4, which is this. And 80 breaks down to the square root of 16 square root of 5. Then simplify each of those. Square root of 4 is 2 times square root of 16 is 4 square root of 5. 2 times 4 is 8 square root of 5. So no matter what, you still get the same answer. But when you choose the biggest number first, it works out better. So choosing this square root of 64 was the best plan. Biggest square root that goes into it. All right, 250, I can see that divides by 25. So 250 divided by 25 is, 250 divided by 25, you get 10. Square root of 25 is 5, so final answer, 5 square root of 10. All right, next one. We have to agree on some things. So if I say square root of 3 squared, that means the square root of 3 times the square root of 3. Well, the square root of 3 times the square root of 3 is the same thing as the square root of 9. Putting those two together, 3 times 3 is 9, and the square root of 9 is 3. So if I have the square root of 3 squared, it will always be the number underneath the radical sign. So square root of 5 times the square root of 5 will just give you 5. Square root of 7 times the square root of 7 will be 7. Square root of 376 times square root of 376 will be 376. So if I have the square root of a times the square root of a, I will always ever get a. All right. A square root is not simplified if there's a square root in the denominator. So you cannot leave a square root in the denominator. We will be rationalizing the denominator. All right, to get a square root out of the denominator, multiply the denominator and numerator by the square root under the fraction line. This is called rationalizing the denominator. Notes, an easier way if you can simplify the radical in the denominator, do that first before rationalizing. All right, let's look at an example. The first one, if I have 1 over the square root of 2, I can't leave the square root of 2 in the denominator. So I'm going to multiply the top and bottom by the square root of 2. So numerator, denominator by the square root of 2, by whatever is in the denominator, the radical in the denominator. So then I take 1 times the square root of 2, which is the square root of 2, and the square root of 2 times the square root of 2 is 2. This answer is acceptable. You cannot leave square roots in the denominator. The next one, I'm going to multiply the top and bottom by the square root of 3. And I'm allowed to do this because the square root of 3 over the square root of 3 is 1, so I'm multiplying by the value of 1. All right, so in the numerator now I have 3 times the square root of 3 over square root of 3 times the square root of 3 is 3. What now can simplify? I see I have a 3 in the numerator and denominator, so I'm going to get rid of those. Final answer then, square root of 3. 4 over the square root of 7. I'm going to multiply the top and bottom by the square root of 7. So in the numerator, I get 4 times the square root of 7 over 7. Square root of 7 times the square root of 7 is 7. All right, this one I'm looking at square root of 18, and that's divisible by one of those perfect square numbers. Remember, the perfect squares are 4, 2 squared is 4, 3 squared is 9. I don't need to go any further because I can see 18 is divisible by 9. So I'm going to rewrite this as 30 over, break up the square root of 18, square root of 9 times the square root of 2. So I'm going to simplify that, so I get 30 over 3 times the square root of 2. And what do you notice about 30 and 3? They can divide. 3 goes into 30 10 times. So now I'm at 10 over the square root of 2. Rules in math, I can't leave, or in math, I can't leave a square root in the denominator, so I'm going to multiply the top and bottom by the square root of 2. Final answer, 10 times the square root of 2 over square root of 2 times the square root of 2 is 2. Reduce that, 10 over 2 gives me 5 square root of 2. All right, reducing that radical in the denominator works well because you can still work it out. It just isn't as nice. So I'm going to try this problem again just to show you. You can multiply the top and bottom by the square root of 18. So you end up with 30 square root of 18 over 18. So now I break up the square root of 18 that's here in the numerator, which means I have 30 square root of 9 square root of 2 over 18. So that gives me 30 times 3 times the square root of 2 over 18. I can see that 30, if 3 goes into 18, let's reduce that. So 3 into 18 will be a 6. But then 6 can go into 30, so I'm going to reduce one more time. 6 is gone, 30 becomes a 5. So final answer is still 5 times the square root of 2. Do this way, it's much easier. Eventually, this will be much more efficient. Don't get me wrong, you still get the same answer, so. All right, next set. Let's see what we have. A radical is simplified when the biggest square root factor of the radicand is 1. Only one square root per term. Use the distributive property and no square roots in the denominator. So let's look at a few more. Oh, you have a worksheet for you today.